See, Standard 12th Maths Chapter 2, Complex Numbers. Exercise 2.8, question number 4. Fourth sum, if 2 cos alpha equal to x plus 1 by x and 2 cos beta equal to y plus 1 by y, show that. So you have to prove four questions. First one, x by y plus y by x equal to 2 cos alpha minus beta and so on. The rest also we are going to do. First, let me take the given one. Given 2 cos alpha is equal to x plus 1 by x. Take x as LCM here. So you will get x squared plus 1. So left side 2 cos alpha, cross multiply. So 2x cos alpha is equal to x squared plus 1. See, x squared, you take this term to the other side, 2x minus 2x cos alpha plus 1 already on the right side equal to 0. We have to solve this equation. So a is equal to 1 and b is equal to minus 2 cos alpha and c is equal to 1. So solution x equal to minus b plus or minus root of b square minus 4ac by 2a. This is the formula for finding the roots. So here what is b here? Minus 2 cos alpha. Already one minus here. So plus 2 cos alpha plus or minus root of b squared. So this whole squared. So 4 cos squared alpha. And this is minus b, a also 1, c also 1. So you will get minus 4 divided by 2a. A is 1 here. So 2 cos alpha plus or minus, you take 4 outside the common. So in that case you will get cos squared alpha minus 1. So when this 4 comes outside the square root, you will get 2 divided by 2. See, 2 is common in all the terms. You take 2 outside. 2 cos alpha plus or minus. See, we have the formula 1 minus cos squared alpha only sin squared alpha. So this is cos squared alpha minus 1. Cos squared alpha minus 1. So here also you will get minus sin squared alpha. Multiply all the term by minus. So minus plus minus 1. So this is minus sin squared alpha. So root of minus sin squared alpha divided by 2. So 2 gets cancelled. So cos alpha plus or minus root of sin squared alpha is sin alpha. Then root of minus. So that is plus side. So this is your x. Therefore, x is equal to cos alpha. You can take x equal to cos alpha plus or minus I sin alpha. So for the given equation, we have the solution this. Let me rub up this. See, in the same way, see the next one they given here. 2 cos beta equal to y plus 1 by y. So y plus 1 by y is equal to 2 cos beta. 2 cos beta. So in that case, you just, if you do the same procedure, we can verify that similarly the same answer you will get. Y is equal to, it is in beta. So cos beta plus or minus I sin beta. So we got the solution. X is cos alpha plus or minus I sin alpha. And y is equal to cos beta plus or minus I sin beta. So using this I am going to prove the answer for the first question. X by y plus y by x. Show that, right? First question, show that x by y plus y by x is equal to 2 cos alpha minus beta. See, for this, so we have two options for x. So let me take x as here cos alpha plus I sin alpha. And same way y also two option plus or minus here. So you take here cos beta plus I sin beta. So take the left hand side terms x by y, x by y. So x is here cos alpha plus I sin alpha divided by cos beta plus I sin beta. This I can write in the exponential form e power I alpha then e power I beta. So exponential one divided by the other, you will get e power minus I take common I common. So alpha, the denominator terms becomes minus. So e power I alpha minus I beta. So take I as common. So e power I alpha minus beta. So therefore this is equal to cos of alpha minus beta plus I sin alpha minus beta. This is your x by y. Next term is y by x. Y by x. So y by x is equal to, see, just it is the conjugate of this reciprocal x by y by x. So you will get the conjugate of this one. Cos of alpha minus beta minus I sin of alpha minus beta. If z is x plus I, we know that complex number z is x plus iy. 1 by z is conjugate of this x minus iy. Same way the reciprocal here. Now I have to add this x by y plus y by x. You add this, you will get 2 cos alpha minus beta. And these two terms gets cancelled. So this is the proof part of the first one, first sum here. Take the next sum, proving part. xy plus minus 1 by xy is equal to 2I sin alpha plus beta. You have to prove. Take the left hand side. So take xy term. So x, as I said, you are taken cos alpha plus I sin alpha. And y is cos beta plus I sin beta. So what you do here, e power I alpha into e power I beta. So in the product you have to add both the terms, both the power, e power alpha plus beta, that is cos of alpha plus beta plus I sin alpha plus beta. So this is your xy. So the reciprocal 1 by xy. So you will get the conjugate. So cos of alpha plus beta minus I sin of alpha plus beta. So here they ask you to subtract here. So xy minus 1 by xy. So if you subtract, you have to change the sign, minus plus. So cos term gets cancelled. So you are getting sin term. 2I sin of alpha plus beta. So this is your right hand side. Come to the third question. X power m by y power n minus y power n by x power m. This is equal to 2I sin of m alpha minus n beta. We are supposed to prove this. So take the left hand side. So here, first you take x power m alone. What is x power m? X, what is x? X is cos alpha plus I sin alpha. This is power m. So by De Moivre's theorem, so you will get the index as here, m, cos m alpha plus I sin m alpha. What about y power n? Cos beta plus I sin beta whole power n. So cos n beta plus I sin n beta. So I have to find what is x power m by y power n. So cos power m alpha plus I sin m alpha divided by cos n beta plus I sin n beta. How do you simplify this? This is e power I m alpha divided by e power I n beta. So therefore, division you have to subtract the power e power I m alpha minus n beta. So this is equal to cos of m alpha minus n beta plus I sin m alpha minus n beta. See, next term is y power n by x power m. Y power n by x power m. Actually, this is the reciprocal of this. So, if z is x plus iy, you will get 1 by z as the conjugate of this. Same way here also you will get it. This is the reciprocal of this. So, I will get this as cos of m alpha minus n beta minus I sin m alpha minus n beta. So this is your x power m by y power n. Now I have to subtract these two. So do the subtraction. X power m by y power n minus y power n by x power m. This is equal to, change the sign, minus plus. So this cos term will get cancelled. So sin term gets 2i sin of m alpha minus n beta. So this is the answer, right hand side answer. Let's come to the fourth one, proving x power m y power n plus 1 by x power m y power n. This is equal to 2 cos m alpha plus n beta you have to show. So take x power m y power n. So already I have shown you. See, as we have seen, x power m as here cos m alpha plus I sin m alpha. Just write that here, cos m alpha plus I sin m alpha into y power n. So cos n beta plus I sin n beta. This is equal to e power I m alpha into e power I n beta. So just we are adding the index e power I m alpha plus n beta. This is equal to cos of m alpha plus n beta plus I sin m alpha plus n beta. So what is 1 by x power m y power n? So this is just conjugate of this. So you will get cos m alpha plus n beta plus I sin, minus conjugate, minus I sin m alpha plus n beta. So you add these two. You have to add. So x power m y power n plus 1 by x power m y power n. This is equal to, so 2 cos m alpha plus n beta. But this is plus I sin m alpha plus n beta minus I. So they get cancelled. So this is your right hand side result. See, we completed all the 4 questions. See the sixth sum. If omega not equal to 1 is a cube root of unity, show that the roots of the equation are minus 1, 1 minus 2 omega, 1 minus 2 omega squared. So here this omega is the cube root of unity. And the equation is z minus 1 the whole cube. So it is a cubic equation. We will get 3 roots. That roots we have to show that minus 1, 1 minus 2 omega, 1 minus 2 omega squared. Given omega is a cube root of unity, that is omega cube is equal to 1, and 1 plus omega squared is equal to 0. Take the equation, given equation z minus 1 the whole cube plus 8 is equal to 0. I have to find the value of z. So z minus 1 the whole cube is equal to, take 8 to the other side, so you will get minus 8. You will get minus 8. See, here z minus 1 the whole cube is equal to minus 8. So z minus 1 is equal to cube root of minus 8. Cube root of minus 8. So actually what is the cube root of 8? 8 factors of 8 are 2 into 2 into 2. For 3 2's. So all the 3 2's you have minus here. See, in order to show that the omega terms, what I do with the minus side, I just multiply this with 1. See, I am taking the cube root of unity also. This is same as this. So in that case, just you split here minus 8 cube root of 1. See, in order to get the result given in the question, I do the substitution which unaltered the given terms. So directly you can write minus 2, but we have to get this answer. So what about the cube root of minus 8? This is minus 2. And cube root of 1. Cube root of 1, what I get the cube root of 1, omega cube is equal to 1, and 1 omega, all the 3 roots, that is the roots are 1 omega squared. So I take the roots as 1 omega squared. All the 3 roots I have to take. So left side is z minus 1. So I have to take all these 3 roots. The first case I take the root as 1 here. Root as 1. So z minus 1 is equal to minus 2 into 1. So z minus, this is minus 2. So z minus 1 equal to minus 2, z equal to minus 2 plus 1, that is minus 1. Second root, you have to take root as omega. So z minus 1 is equal to 2 into omega. So z is equal to 2 omega plus 1. Sorry, here minus 2. This is minus 2. Minus 2 omega plus 1. Third one, root as omega squared. So z minus 1 is equal to minus 2 omega square. So z is equal to minus 2 omega squared. Take minus 1 to the side. So you will get 1 minus 2 omega squared. This is 1 minus 2 omega. So the 3 roots are here. The 3 roots are minus 1, minus 1, 1 minus 2 omega, 1 minus 2 omega squared. So that's what you have to prove here. So we proved this answer. See, just you have this idea. Because of the answer required in terms of omega, we just multiply with the 1. So, but which is not annulled the previous step. So this step is just important one. Okay, thank you.